Hello and welcome everyone to Intrepid Museum's live virtual programming. Thank you so much for joining us today for Star Stories. We are so thrilled that you're tuning in and we'll be answering a number of your questions throughout the program. My name is Alicia and I'm an educator at the Intrepid Sea, Air, and Space Museum in New York City. I'll be your host today for the program, and just as a reminder, the museum's live streams are free, and if you'd like to support us in delivering this content, please click on the link in the comments or in the description. So feel free to use the chat today to say hello. Let us know where you're tuning in from. Let us know if you've ever been to the Intrepid Museum before. And of course, if you have any questions, you can feel free to put them there as well. So today we are going to be talking a little bit about the Intrepid's connection to space. So why we are a space museum. And then we are going to talk a little bit about the stars and also a few constellations that we can find up in the night sky and how the stars have been used to help guide people out at sea for generations. You see, a long time ago, we didn't really know much about our world other than what we could see immediately around us. And it wasn't until we started really going up into the sky and then eventually into outer space that we really got a sense of our planet and the rest of our solar system. And it all just started by us looking up. So let's go ahead and get started. So everyone, in case you aren't familiar, this is the Intrepid Museum. It actually is inside of the former USS Intrepid, which was built in 1943. It served in 3 wars, World War II, the Cold War, and the Vietnam War. And then it was retired in 1974 and was made into a museum in 1982. So we are currently docked right off the shoreline of Manhattan in the Hudson River, just a few blocks away from Times Square. Now, if you're local, maybe you have visited before, or maybe you've passed us along the way on the highway there. It really is a beautiful thing to see on the outside. It is gigantic. It's really hard to miss. But really, inside is where the magic is, where a lot of our really cool artifacts are. For example, right here. So one of these is here on the right, one of our 4 propellers on the Intrepid. Now, these are the things that helped us to move through the water. And that, of course, is why we are a sea museum, because we are a naval ship out at sea during times of conflict. In this image on the left, you can see the ship actually racing along through the ocean while it was in service. Now, at the Intrepid, you're also going to see a number of planes, and that is one of the things we are definitely known for. And because we carried planes, we have a very special name in particular, the type of ship. Can anyone tell me in the chat what kind of a ship the Intrepid is? Anyone know? What are ships like the Intrepid called? So these are big, big ships that have airplanes on them. They help them to launch and to land. And actually, here's a couple that you can see here right on the right. We've got the Avenger, that big blue one on the left from World War II. That was a torpedo bomber. You can kind of see the torpedo right underneath it. We have also got the white one on the right, the Fury, which is a jet plane. It flew really, really fast during the Cold War. So planes like these are, of course, why we are an air museum. All right. Intrepid could fit up to about 100 planes inside at a time. Again, it could also launch and land those planes from the flight deck. So you can kind of think of it like a floating airport. So yes, I see Marie Henshaw in the chat says carrier. Our ship is in fact something called an aircraft carrier because it carried aircraft across the ocean. Very good. But a lot of people come to the museum and they still wonder, why are you a space museum too? That space part, really confuses people sometimes. So why are we a space museum? Well, take a look at this. Can anyone tell me what this thing is? All right, we've got this big black kind of almost light bulb shaped thing here. It says United States on it. Maybe that's a little bit of a clue. It's got a flag. Some people, when they look at it, they say it kind of looks maybe like an ice cream cone that's been tilted on its side, or maybe it looks like a megaphone, something you might shout into to be louder. So this thing, everyone, is something called a space capsule, and it is very special because this is how astronauts used to go up into space. So looking at it, and Harris Hussein says Mercury, yes. So looking at it, you could probably tell, first of all, it's not very big. Maybe you can tell me in the chat, how many people do you think could fit inside of this capsule? What do you think? Capsules like these, everyone, they rode up on the top of a rocket. So, of course, the rocket's the thing that goes up into space. There's lots of fire that comes out of the bottom to get them up there, right? But then once they get into space, they separate these things, these capsules. They separate from the rockets, and then they're up there floating around to complete their missions until they come back home. So a while ago in the 1960s, during that Cold War era, NASA, our space program, was part of something called a space race with the Soviet Union to get all the way to the moon. But of course, you don't just roll out of bed and end up on the moon, right? You have to take a number of baby steps to get there first. So, some of these baby steps might look like first figuring out, of course, how to get into space. So building those rockets. But then once you're up there, well, you got to figure out how to breathe, right? You have to figure out how to eat if you're going to be up there for a long period of time. Also sleeping, right? Working. These things that we take for granted every day here on Earth, a little bit different when you're up in space. So these capsules were part of some of those early steps. I saw earlier in the chat, Mercury. Yes, it was part of something called Project Mercury. And this is what the Mercury capsule, the Aurora 7, looked like. All right. Now here, actually, you can see it is on the top of the rocket on the right. All right. It's that little black cone on the top there. And for some perspective there, yeah, it's actually pretty small. I see we have some numbers that came in here through the chat. We said 2, 1, 4, 1 man. So yeah, the answer is 1 person could fit inside of this Mercury capsule. Pretty small. Now, in 1962, an astronaut named Scott Carpenter, who you can see here, he went up inside of a Mercury capsule just like that one. Now, have we ever heard of that word before? Mercury. All right, what is Mercury? Have you ever heard that before? Why do you think that they called these missions the Mercury program? Any thoughts about that? Let's take a look. You might have heard the word Mercury before because it is the name of one of our planets, right, in the solar system. It and many other planets got their name from Roman mythology. So Mercury was actually the name of the messenger god. You can kind of imagine him like the mailman, all right, for all the gods. He was known, though, for being very, very fast. And oftentimes you might actually see him depicted looking kind of like this. So you see he's got wings on his helmet, he's got wings on his shoes and his little staff there, and all that wing power is supposed to really add up to help him to go really, really, really fast. So the planet Mercury is both our first planet from the sun, and as its name might suggest, it is also the fastest planet. 1 year on Mercury takes only 88 days. Well, it takes 365 days for us here on Earth to go around the sun. But Mercury, very, very short, only 88 days. So America wanted to be the first and the fastest to get to the moon. And they thought, perfect, we will take our name after Mercury. So back to the Aurora 7 and Scott Carpenter, though. At this time in the space program, when the capsules came back home, they wanted to pick a softer landing spot. So rather than landing, in a desert or on the side of a mountain or, on somebody's house or something like that, they decided they were going to splash down into the water with some parachutes to slow them down. A little bit softer, a little bit easier to aim for because 70% of our Earth is covered in water, right? Well, of course, afterwards, since they're out there floating around, you can't just leave your astronauts floating in the middle of the ocean. Someone would have to go then pick them up. So a helicopter would come to rescue the astronaut. And you can actually see these pictures here. First of all, this is a splashdown from the Apollo missions on the left. And then on the right, it's actually Scott Carpenter and that Mercury capsule that we saw earlier. Here is Scott Carpenter being retrieved by a Navy helicopter right afterwards. So eventually, you'd pick up your astronaut, and then the next thing is divers would come to help to retrieve the capsule. They would bring it then on board the closest ship to eventually end up where else? In a museum, right? Now, the Intrepid is actually really, really lucky because it got to do this whole, program of picking up capsules and astronauts not once, but twice. And it played a really important role in this whole early process of NASA. And after, we picked them up from space. So really, really exciting opportunities and a really cool connection that we have. And again, that is why we are a space museum. And in fact, here are some pictures of Scott Carpenter on board our ship, the Intrepid, right after he was picked up. He's there in his, slick, shiny Mercury spacesuit, surrounded by officers and onlookers on board the Intrepid after being picked up in 1962. So a very, very, very special occasion. Now, after the Mercury missions and after Scott Carpenter splashed down and we picked him up, NASA sent up some other astronauts. So here, actually, you can see Gus Grissom and John Young. They went up inside of the Gemini 3 capsule. And similarly, when they were done, they also splashed down into the water and were retrieved by the Intrepid the same way. But I want to talk a little bit about the name, again, of those missions for a second. Now we're talking about the Gemini missions. So what does Gemini mean? Tell me in the chat if you've ever heard that before. Gemini. So take a look at these pictures here. And let's think about how it might be a little bit different than the Mercury missions that came before it and what we noticed about, in particular, the Mercury capsule, maybe the size of the Mercury capsule. And again, remember, this is called now Project Gemini. Has anyone ever heard that word before? What does Gemini mean? Yeah. All right. In the chat, Gina Rose says the twins. Excellent. So again, everyone, here are those two guys again, Gus and John. And yes, the word Gemini is actually a constellation up in the sky. Now, what is, first of all, a constellation? You've never heard that word before, right? So it's basically a picture in the sky, and it's made up of a grouping of stars. A long, long time ago, people would look up into the sky. They would see these dots of stars up in the sky, and they would make pictures out of it. They would connect the dots, they would create pictures, and they would tell stories about what they saw up there. So yeah, take a look at that Gemini constellation there on the right. What does it kind of look like to you? All right, so in the chat, again, Gina, it said the twins, right? And that's exactly what it is. It is the constellation of the twins. So thinking about that, thinking about our friends Gus and John here, who went up into space together, now we can start to understand why this is called the Gemini Project. This was the first time that NASA sent 2 astronauts up into space together. All right. So a really, really, fitting name here as well. Mercury, first and fastest, all right, to get to the moon. Gemini, first time we sent 2 people up into space. And these Gemini missions were now the next step towards getting to the moon. This is now longer missions. Now we were eating different types of food. Now we were actually learning how to do spacewalks and leaving our capsule. So again, baby steps to get there, but also a really good name. And I see Harris Hussein in the chat says corned beef sandwich. That's right, my friend. A very funny story about the Gemini 3 mission, actually, is they snuck on board a corned beef sandwich, and they were not supposed to, but they did anyway. So everyone, I want to pause here and see if we have any questions today as we get started. Any questions to start off about Intrepid or maybe our early missions into space? So let's see what we got. Any questions? Were any other NASA programs named after Greek mythology? Yeah, so mythology, Greek and Roman mythology, pretty much all of them, actually. You've got, of course, Mercury and Gemini. Then, of course, Apollo, which took us all the way to the moon. Ironic, actually, because Apollo is actually the sun god, but they really liked the idea of, him like pulling his chariot of fire across the sky, kind of like all those powerful rockets streaking across the sky there, and all that represented in the mission. But, now we've actually got the Artemis missions coming up. Artemis is the twin sister to Apollo, which is, very clever, very appropriate, but also kind of symbolic now because it is the name of our missions that are going to bring the next man and the first woman back to the moon. She was the twin sister. So a nice little connection there as well. But, it's actually kind of interesting. Project Mercury was originally supposed to be called Project Astronaut. And this was even before we had the term astronaut. Remember, they actually got that word from the naming tradition that started with the Greeks, with the Argonauts. So you might have heard of like Jason and the Argonauts. Those were the guys going around the ship, the Argo, looking for the golden fleece. So this idea of, naut, N-A-U-T, it's like nautical. It's like ships. And so they had these. Then eventually, as people started flying things like hot air balloons up into the sky, right? Those were called aeronauts. But they realized, they didn't really want to call it, Project Astronaut, because they didn't want it to be so much about the people, so much as the mission as a whole, and all of humanity going together. So they decided to go with Mercury instead. But yeah, we've got tons of rockets. We've got Thor and Atlas and Centaur and Saturn rockets. We've got spacecraft like Aquarius, and so all kinds of things. They really stuck with that naming tradition. They went with it. Good question. Any others? How many constellations are there? So there are 88 officially recognized constellations in the night sky. Of those 88, 52 of them are visible from our northern hemisphere. So that's north of the equator. And the constellations that we recognize were, again, originally described by these ancient Greeks and ancient Romans. And they really do correspond with their mythology. But while, they're certainly not the only civilizations to find these, images in the night sky, those are the ones that are most recognized today, though. There are, really well-known ones like Ursa Major and Orion and the zodiac signs. But there's also some really random ones. There's a unicorn and a giraffe, even a microscope. These are ones that kind of came later, so they don't necessarily have stories associated with them, but you could always make up your own story. So yeah, all kinds of fun stuff up there for sure. All right, everyone. So moving on here, now you can actually find the Gemini constellation in our night sky, and I'm going to show you how in just a second. So right now I am actually going to, here we go. I'm actually going to switch over programs, and I'm going to pull up this program called Stellarium. Now it is a free program that you can download. And it's going to show us what the sky looks like in real time and what the stars look like. And of course, that might sound kind of silly because, well, it's daytime, so we shouldn't technically be able to see anything, right? But with this program, it is actually going to allow you to see some of those things. So if you give me just 1 second here, I'm going to go ahead and share that for you. Let's see here. It's giving me a little bit of difficulty doing that. All right, so it's not letting me do it right now. So actually, I'm going to do something else. There's another way that I can show it to you. And it is online. So it is stellarium.org, and we can actually look at it through the internet. This is going to be called Stellarium Web. Here we go. So again, this is going to show us what the stars look like in real time in the night sky. There we go. All right, so I'm going to go ahead and share that. Technology. Excellent. So everyone, if we take a look right here, we can see Stellarium. Now this is the night sky. Of course, this is nighttime, but it is right now daytime. So things might look a little bit different to us during the day. Of course, during the daytime, we've got something called an atmosphere. There we go. Looks like I'm a little frozen there. There we go. We've got, of course, an atmosphere that turns everything blue, right? So when everything is blue, does anyone know why that happens? Does anyone know why we look up into the sky and we see a blue sky? Tell me in the chat if you happen to know. Here on Earth, if we're looking up in the night sky, also things might look a little different in the night sky as well. We might not be able to see as many stars up there. We don't really have the chance to be able to see as many as we can see here because of light pollution, right? We've got a lot of light that's coming up from our city that's really helping to cloud everything out. So it can be a little bit more challenging. But the sky, everyone, when you look up at it during the daytime, it looks blue because so much of our Earth here, it's actually surrounded by a very special thing. It's surrounded by this bubble. It protects our Earth. It scatters blue light really, really well. It takes the light from the sun and it scatters the blue spectrum in particular. And that is why we can't really see stars during the day. So although the atmosphere, that bubble around us, really does do a lot of really great work helping to stream out some of those charged particles from the sun that otherwise, would kind of give us skin cancer and, really, really cause a lot of havoc here on Earth, it helps to protect us. It helps to bounce a lot of those solar rays away from us. But again, it doesn't do a great job showing us stars. Now, technically, everyone, when we do look at the sun, when we look into the sky, we can see one really big star, the sun. But it is so bright that it really does mess with our view of the rest of the stars during the day because of scattering that light. But in this program, we can see what it looks like without the atmosphere. So we can actually take a look up into the sky and see some really amazing things. So throughout history, when people have looked up into the sky, it might have looked like a bunch of random dots on a piece of black paper or something. In fact, the Native Americans in the Pacific Northwest believed that at one point the sky was nothing but darkness. And they said that a young member of their tribe made a mask out of wood. He set it on fire, and then he began to travel across the sky to light it up for us. So effectively, he was the sun. And then at night, the stars are actually sparks and embers that flew out of his mask. But cultures also started to notice that, well, the stars are always kind of in the same place, right? Their patterns always stayed the same in the sky. So as they realized this, they eventually even started to map out the sky, and they identified groupings of stars too. Now, remember before I showed you that picture of Gemini, and the lines were all drawn out and connected for us? Well, of course, looking up in the sky here, we don't have lines like that for us. We have to use our imaginations. But what is really neat about this program is that I can add the lines to the sky for us, and we can more clearly see some of the constellations. So check this out. Look at these lines, all these different pictures that show up here. And believe it or not, I can also add some other cool stuff like artwork too, to really bring it to life. So this is kind of what everything would look like right now if we look up into the night sky. All right, you can see all these different pictures of people and animals. And in particular, if we want to see, anything maybe that we've seen before, you can look up here. All right, and we can see, we're looking around, some of these things that I mentioned before, right? We can see Ursa Major, for example, or Orion and Orion's famous belt. But let's go ahead here too. I'm going to zoom out just a little bit. All right. And this is actually what everything would look like kind of at night. If I were to go backwards in time here, there we go. We can see that atmosphere, right? We can see what it looks like during the day. All right, we can go back to real time here, which is right now. There we go. That's actually what I wanted us to start off with. But if we look up into the sky here as well, and I can turn off the atmosphere, this is what I was looking for before. This right here, everyone. Oh, let's turn off that atmosphere. There we go. Now we can actually see Gemini. Remember, we just talked about the Gemini constellation and the Gemini capsule. So there it is in the night sky in real time. All right, so we can see that right here in the western sky right now. And Gemini, of course, again, is the twin brothers. Now, again, there is actually a story, believe it or not, that goes along with this Gemini constellation. The ancients saw these groupings of stars, and they decided to come up with stories to teach lessons, to remember their gods, or important, issues that were important to them, and principles of just how to live your life that were important. So there is a story that goes with Gemini. They said, once upon a time, there were two boys, Castor and Pollux, and they were best of friends. Castor's dad was a regular guy, but Pollux's dad was Zeus, king of the gods, which meant that Pollux could live forever. But that didn't bother them. They were still best friends. They did everything together. They played together. They went to school together, and you never saw one of them without the other one. Now, eventually, when they got older, they both became great warriors together too. But one day, a war broke out in their country. So Castor and Pollux both went to go fight in the war, but then something very sad happened. Castor was killed in battle. So his brother Pollux, of course, was heartbroken because his best friend was gone. So Pollux went to his dad Zeus and he said, I know I am supposed to live forever, but I really miss my brother. Would you let me give half of my forever life to my brother so that I could be with him longer? And Zeus was so touched that his son was willing to give his life for his brother that he did something even better. Zeus brought Castor back to life and let them both live for half of forever, however long that is. And then when that was up, he put the two brothers back up into the night sky so that they would never have to worry about being separated ever again. So everyone, Gemini is, again, a constellation, and it reminds us about the importance of friendship and brotherly love when we look up into the sky. So everyone, can you think of any other constellations that, maybe you've seen, or, maybe throw in the chat for me? Maybe if you know your zodiac sign, which is based, of course, on the time of year that you were born, that is also a constellation. Depending on what time of year you were born, you will be associated with one of these zodiac signs and constellations. For example, my birthday is at the end of April, so I am a Taurus. And I believe, when the school year starts up, I know I've got a bunch of friends who have birthdays in September, for example. I know that they are some Sagittariuses. So let me know what your zodiac sign. I see a Leo, the lion, says Gina in the chat. Excellent. So whatever your zodiac sign is, that means that the sun was moving along its path, something called the ecliptic, and it was currently in that constellation while it was moving through it. Now, everyone, another star grouping that is pretty famous and that you might have heard of is something called the Big Dipper. All right, but let me ask you a question, everyone. Do you think the Big Dipper is a constellation? Let me know in the chat. Is the Big Dipper a constellation? Yes or no? So let me go on over here. Let's find the Big Dipper. All right, so we've got the Big Dipper right here. Everyone, the Big Dipper is actually not a constellation. It is a smaller grouping of stars called an asterism, right on the back half of Ursa Major, right here. The Big Dipper is part of the constellation Ursa Major, which actually means the Great Bear. So you can see there's this big bear right here who's kind of upside down. Now, the back half of Ursa Major, so it's kind of the back here, and then this big long tail, which is kind of funny because bears don't usually have very long tails like that. But the Big Dipper, it's actually got two stars on it that are called pointer stars, and they point to the North Star. So these stars right here are these pointer stars. It's the front half of this little cup of the Big Dipper. And again, if you're not familiar actually with the Big Dipper, it's basically like a spoon. And right now, the way we're looking at it, because of the time of year, it's upside down right now. So it's like a big ladle or a big spoon. But these two front stars here, they're called pointer stars, and they point us to the North Star, which is, of course, Polaris. And that is the very, very important star for many people. So if you were to look at these pointer stars and you go 1, 2, and then you hop all the way straight down in that line, you're going to be led right here to Polaris, all right, the North Star. And the North Star is actually the very tip of the tail of Ursa Minor, the little bear, which you can see right here as well. So you got the big bear and you've got the little bear, and there is that tip of the tail right there. Now, what's great about Polaris, everyone, is that in the Northern Hemisphere, this particular star, Polaris, is always in the north. You can see that cardinal direction N right there. It actually does not really move at all. Now, it's very important because Polaris was actually what navigators used to map out the night sky. So let's see if this works here for me. If we were to fast forward time, everyone, you will actually start to notice that the constellations will rotate around Polaris, but that one fixed point is actually going to stay right there. Isn't that something? So, of course, if you are out at sea and it is, very dark outside, you can see a lot of stars. But let's say that you can't necessarily see any landmarks. You can't see any land. You can't see any buildings, of course. And let's say that you don't even have any equipment to help you. Well, if you have one point that doesn't move throughout the sky and you always know where to look for it, that means you will always know that you are heading in the direction of north. So it's very, very helpful for many sailors. And if you know where north is, you can then figure out where south, east, and west are just based on that point. Now, there are actually a number of stories about the Ursa Major constellation in particular. And this one is told by the Iroquois Native American tribes in the northeast of the United States. They said, once upon a time, there was a great and terrible bear terrorizing the land and eating all of the food. So all of the tribes got together and decided they needed to do something about that bear. So they sent their 3 bravest warriors in all of the land to go hunt down the bear. Well, the warriors were really good, but the bear was always one step ahead of them. They chased that bear all around the world, through the mountains, through the oceans, through the desert, and finally the warriors were catching up to the bear. So the bear took one great giant running leap. He jumped up into the sky where the warriors couldn't follow him, but right before he got there, one of the bravest of the 3 warriors let loose an arrow from his bow, and he struck the bear in his back leg. So the bear got away, but the warriors vowed if he ever came back down from the sky, they would be there and they would be waiting for him and ready. So the warriors actually always know, they say, that he's getting closer to the earth. He's creeping back down again because a little bit of the blood from the bear's wound from that arrow drips onto the trees and changes the leaves' colors. So this was actually a way for them to explain the seasons. So everyone out there in the chat, can you think of a time when the leaves on our trees change color? Maybe they turn to like a reddish color, like the blood from his wound. Anyone happen to know? Maybe. They always say that it happens at the same time of year. And of course, that is the fall. They said that was when the bear was coming closer to earth. His blood's dripping onto the leaves. And actually, what's great is that with this program, I can actually show you what that would look like. All right. So everyone, if you imagine that it is, let's say it's about 8 o'clock at night. All right, so we're going to fast forward here to 20. It's about 8 o'clock at night. All right, so this is about the time. This is about the time when. Oh goodness, this is about the time, everyone, when the sun's going down and we can see things, right? Having a difficult time with this program again. Let me drag it. There we go. All right. Let's say it's about that time. It's about 9 o'clock. Great. So everyone, if you look at this, all right, and I'm actually going to make it a little bigger for you. All right. So everyone, if you see right now, all right, here's Ursa Major. Ursa Major right now is heading down towards the tree line here, right? All right. So right now it is August. So right now, of course, we still have our green trees. We still have, we still have lots of green in our trees. It's not quite turning anything yet. But in the next couple months, when it gets into fall, it's going to start to change a little bit. So look what happens. If I fast forward us to September, keep an eye on Ursa Major here. Ursa Major is getting closer. And this is about the time of year where his back leg is going to start to hit that horizon and start to drip onto those trees. Now, that's September. October, now he's just crawling right alongside here, right? October is definitely where our leaves are going to start to change. Then we have November. Certainly have a lot of very, red, orange, beautiful colors in our trees. And then December, of course, we're losing a lot of the leaves in our trees anyway because it's cold and it's snowing. But at this point, this is where he's starting to head back up into the sky. January, February, there he is climbing again. March. Now the trees are actually starting to bloom a little bit, right? So now we're actually getting some buds and things are turning green again. April, things are blossoming, lots of light green, beautiful green colors. May, he's way up in the sky. June, July, August, but now he's starting to creep down again. So this was, again, a way that they could explain why some of these different, things were happening seasonally for them. And so they associated it with the location of Ursa Major in the night sky. Now, we talked a little bit, everyone, about asterisms, right? We said, the Big Dipper is an asterism. The Big Dipper, of course, being the back half here of Ursa Major. But there's actually another pretty famous asterism that's in the night sky. Pretty easy one to find, too, especially here in New York. You can still sort of see it. Does anyone else have a guess about a cluster of stars that maybe you've heard about before? And I'll give you a little bit of a hint. This is a cluster of stars, everyone, that might be associated with something that you might wear, an article of clothing that might help, hold up your pants, that sort of thing. So, everyone, of course, I am talking about Orion. And let's see if we can find Orion up here in the night sky. Zoom out just a little bit. So Orion, everyone. Orion is very easy to spot because of the fact that it's got that belt. All right. So the Orion's belt is 3 stars right in a line. And I see now. I know why he's not coming up. Let's find him right over here. 3 stars right in a line that is really easy to identify because of how bright they are and because of the fact that they are right there in that straight line. Look at that. So Orion is easy to see from New York. And there is another story associated with this. As you might be able to see in this picture, he looks like a hunter, doesn't he? So he has some really fun stories that are related to him. In Greek mythology, Orion, of course, yes, was a great hunter. He was even said to have killed Taurus, the bull, who's right next door to him, right there. Again, Taurus is my zodiac sign. Maybe you are too. And yes, so he was said to have killed Taurus, the great bull, right next to him. But he also liked to brag a little bit about all of the things that he killed. All right. And of course, that's not very nice. We do not like to brag. We do not like to go around telling people that you're better than them. That's not very nice. Well, Orion was friends with Artemis, again, goddess of the hunt and the moon. And she really respected animals. She believed that you really should only be killing animals if you needed them for food or for survival, not just for sport. But Orion kept wanting to show off and just going around killing animals for fun. So the other gods took note. And they decided to punish Orion by sending a giant scorpion after him named Scorpius, which you might have seen up here too. So they fought long and hard. And to this day, they are actually still chasing each other through the night sky. So everyone, I could actually show you this as well. But here's the interesting thing. You can never really see them at the exact same time because of this curse that they put on them. They're on opposite sides of the sky. So Orion falls in the west on the horizon, just as Scorpius rises in the southeast. So they are always chasing each other. So everyone keep an eye right here. You've got Orion, right? Now watch as I fast forward through time. You're going to see him sink on the horizon. And then right on the left, you're going to see Scorpius the scorpion. There he is, that big red eye Scorpius right there coming up in the south. So, you can see as he ducks down, Scorpius is there. They'll never catch each other. That's his curse, constantly going around the world. It's actually kind of interesting. Scorpius is actually the same constellation as Maui's fishhook. If you've ever seen the movie Moana, which is set in Polynesia in the Pacific Ocean, right? There's that hook that the demigod Maui uses to pull up the Pacific Islands, like Hawaii in their legends. So again, that is another example of another culture who saw something in the sky. The Greeks saw it as Scorpius, but they saw it as this fish hook, and it's this Polynesian constellation tale about Orion and Scorpius there too. Now, actually, Orion has another Polynesian tale associated with it as well, which I can go back and tell you about that one. So again, this noticeable 3 stars up in the sky here of Orion. So these 3 stars have something to do with this constellation, with this asterism of these 3 stars has to do with that story. And this story is a Polynesian tale about a little girl and a baby shark. I know that's going to trigger some songs in people's heads, but I'm not going to sing it. It's an earworm. So everyone, in Tonga, which is an island near Fiji out in the Pacific, the 3 stars that form Orion's belt tell the story of Hina and her pet shark. So Hina was a beautiful young girl, and one day her brothers were out fishing, and they caught her a baby shark as a present. So they gave it to her as a pet, and then they created a pool in the reef where the shark could live, and Hina would watch over it. But one day there was a very violent storm, and the storm blew down all these buildings in the island, and they damaged the reef where the shark was living. So the waters rose up, it swept the shark out to the big wide ocean, and the shark swam away. Now, of course, Hina was devastated. She was so sad that she begged her parents to take her out to sea to find her pet shark. So she and her parents searched the ocean far and wide until finally a fin emerged from the waters. And Hina knew that it was her shark. So she begged and begged and begged to return with her. But the shark, he had tasted freedom. He's out in the big wide ocean, and he did not want to go back to his tiny little reef pool. So Hina was so upset she could not bear to be parted from her friend. So she prayed and prayed, and the canoe that had she and her parents rose up into the heavens and became the stars here of Alatulu, or three in a boat. And so that is those three stars. They say that that is Hina and her parents up in the sky, staying there with that baby shark. So there you go. A whole nother a story that's associated with the stars, and of course, stars that are commonly known in the Greek mythology, but also can be seen another way as well. So, everyone, I would like to see now if we've got any other. Try to fix this out again. Oh, yikes, you can't see me now. Okay, so I want to see if we have any other questions in the meantime. Are there other constellation stories about the seasons? Oh, yes, there are a ton. So the constellation of Virgo, for instance, which is often depicted as a beautiful maiden, right? She's often recognized in many cultures as the bringer of spring. So the ancient Greeks linked that constellation to their myth about Persephone, who was the goddess of the spring. And if you know that one, Persephone was the daughter of Demeter, the goddess of the harvest. And one day she was out gathering flowers, and Hades, the god of the underworld, kidnapped her and brought her to the underworld. So her mom, of course, was very upset. Obviously, she stopped working as the goddess of the harvest, so the earth started to turn cold and really dry up. And finally, Zeus, the king of the gods, declared, all right, Persephone has got to be returned. Hades, you must let her go. Everything is dying. But right before doing so, Hades offered her a feast, and she had a few pomegranate seeds. And they said because she tasted the food of the dead, she then had to spend half of the year in the underworld with Hades. So they say that whenever Persephone goes to the underworld for half the year, Demeter's very sad, her mother's very sad, and it's winter. But then spring comes when she returns to the land again. And then the same thing happens with the Virgo constellation. In the spring and the summer, it can be seen right overhead, and then it ducks beneath the horizon completely, actually. And it's missing from the sky in the fall and the winter. So there's a ton of stories like that. Again, just like the Ursa Major constellation, where it was going around that star and dipping on the horizon to change the leaves' colors. Same thing. It's a way for them to kind of make sense of the seasons and what's going on. All right. Any other questions? Why can't we see many stars in New York City? Yeah, so I mentioned that the sun, scatters light around the atmosphere during the day, which is why, really none of us can see it during the day. But same thing kind of happens coming up from the earth at night here in New York City, or really in any big city. So when you've got a lot of lights, so street lights and cars or tall buildings like we have here in the city, things like that give off a lot of light, it's giving off this light pollution, it's called, from the ground up. So that light also gets scattered too, and it blocks out our ability to see the stars up in the sky. But if you ever go camping someplace, it's maybe a little bit more out of the way from all the lights of the city, right? You will see just billions of stars out there. It's really, really breathtaking. So yeah, stargazing can be a little tricky here in the city, but we can see some on clear nights, but it's certainly not as many as you'd see out in the desert or something like that. So everyone, I did mention Moana earlier, so I do want to leave you with a fun little activity that you can try out. If you've ever seen Moana, when she's out there adventuring in the ocean, you might have seen her use some celestial navigation, right? So she uses the stars to figure out where she is while she's out in the water and where she's going. And remember, we said Polaris, the North Star, was really great at helping sailors to figure out where north was, and ancient navigators had a few other tricks up their sleeves as well to figure out where in the world they were. And kind of literally, because they used their hands. Bad joke, I know. Now, it is certainly not the most precise way of doing things. Eventually, they did, of course, develop gadgets to help them out. But I'm going to teach you a few things that you can use with just your hands today. So we are going to be looking at something called latitude. If you've ever seen a map, you might have noticed that there are these lines that go side to side and up and down on them. So these side-to-side lines, everyone, there's something called latitude lines, all right? We've got latitude, and then the up and down ones are called longitude. And they can really help you to figure out where something is, just based on these numbers, you can calculate out the directions for it. But that's really helpful, especially if you're sailing out in the ocean too. So the equator is the line that goes around the center of the Earth. We say that that is the line that is at 0 degrees latitude, so right around the center there, kind of like, again, a belt, right on the center there. And then depending on whether you go above or below that line, you are going north or south, that many degrees. So the Intrepid actually used coordinates just like that when it was sailing, but of course, they had much fancier gadgets to tell them where they were. Now let's pretend, all right, if you were outside looking up at the sky and you were to extend your arm out, all right, just like that, just to the side. All right, if you were to extend your arm out, this is the relative distance that you would want to be looking at it. And at this distance, the width of your pinky finger is said to be 1 degree. All right, so the width of your knuckles then across your hand is 10 degrees. And then the length of the whole span of your hand outstretched from the thumb here to the tip of your fingers, just like this, kind of turn it sideways a little bit to help you. That width is 20, all right, 20 degrees. So based on those measurements, using your hands, 1, 10, and 20, you can actually count out how many degrees up from the horizon the North Star is to determine your latitude. So how far north you are on the planet if you were to look at a map. So for example, New York is just over 40 degrees north on a map. So you could figure that out a few ways. You could go fist over fist, right, from the horizon. So that would be 4 fists up, and you would see the North Star right about there. Or you could also do, 2 hand spans like this up from the horizon, just like that. That would be about where it is. Or, if you really wanted to, you could stack your pinkies like that, but that might take a little bit longer. But if you're not in New York City, let's say you're somewhere a little bit further south. Let's say you're Mexico City. That's 20 degrees north. So same thing. You could just use 2 fists, and the North Star would actually be a little bit closer to the horizon at that point. Or you could just do 1 outstretched hand for 20 as well. So wherever you are, you can estimate, if you're north of the equator in the northern hemisphere, you can estimate how far north you are just using your hands and the North Star. Now, the people who live in the southern hemisphere or below the equator, actually people like Moana, believe it or not, they actually can't see the North Star, which is a little bit unusual. We're so used to seeing it up here in the northern hemisphere, but it's true. So we actually see some constellations that they can't see in the northern hemisphere, and they see some things that we can't see too, because the Earth is slightly tilted on its axis. So if we take, a look, if we were to look at the southern sky, you would actually see some constellations that are a bit different. So you would, of course, see Scorpius or Maui's fishhook again, but it really reaches up over the southern sky. So again, these Hawaiian Islands and the idea of this hook, drawing it out from the horizon there, that really is a lot more pronounced in the southern hemisphere. But they don't have a northern star there. Instead, they use a constellation called Crux, or the Southern Cross, to help them find their southernmost point. And there are 2 stars to the side of it that are also pointer stars too. So they have to do a little bit of math, believe it or not. In the southern hemisphere, they have this long imaginary line that they have to draw from the 2 stars in the Southern Cross. And so once it hits there, there's another one where they have to go perpendicular to it. And that center point in their imaginations where it all joins together, that intersecting point is where their southern point is, right? So you could say it's like the southern star, but it's not actually a star. So we have it a little bit easier, I will say, here in the northern hemisphere. We can just look at a point. They have to do a little bit of calculations in their head to figure it out. But same idea. If they can figure that out, they can use their hands as well to figure out where that imaginary point would be. So, if you were in Australia, let's say, that's also about 20 degrees south. So again, that would just be 2 fists up, and then they would know that. So it's pretty cool. You can use your hands to figure out your latitude if you're ever lost out at sea. Just like Moana, again, you've got 1, 10, and 20. So if you ever are lost out at sea, all I can say is, you're welcome. Now let's head back to New York, everyone. Thinking about this, the last thing I want to mention is, of course, these ancient cultures noticed constellations and star groupings, but they also noticed some other really big, bright things in the sky that didn't stay put or really travel in a pattern that they predicted the way that stars do. Instead, these bright things they saw in the night sky wandered through the sky. So the ancient Greeks named them for their word, which meant wanderer, which was planetes, believe it or not. And just like it sounds, that's where we get the word planet today. So it's really these stars that kind of wander through the sky. They're very bright. So you can see planets in our night sky. For instance, of course, Mars, planet that's been in the news quite a bit lately, of course, since we landed the Perseverance rover on it. But Mars can be seen in the night sky as a bright red dot, kind of like a big glowing red eye, or blood in the sky. Mars, of course, is the Roman god of war. That's how it got its name. But it gets its actual color, that red color, because of all of the iron oxide that's covering the surface of Mars, that really dusty red surface that it has there. And Perseverance is actually up there right now searching for possible signs of past life in an area called the Jezero crater, which scientists believe was once an ancient river delta or a lake at that point too. So very exciting thing that we're looking at following Mars around. And also we can see things like Venus, also very bright in the sky. And if you've got a telescope, you can see more distant ones too. Neptune, for example, it has a blue cast to it as well. And then of course Saturn with those beautiful rings. We can't necessarily see them with the naked eye, but with a telescope, you can see some really amazing things. So everyone, as we round out, I want to see if we have any other questions today. Any other questions? Why do stars twinkle? Yeah, so stars, they often give off that sort of flickering, twinkling movement a bit. And that's really actually light bending, really, as it comes through, and blending with the atmosphere. As it comes through, it actually slows down. It gets a little bit twisted, and it makes it look like they're twinkling from here on Earth. But it really is actually kind of an illusion to us. If you were to go into space, the stars would actually look a little bit different. So that is kind of, an added effect. They'd look a little bit more steady from up there. So from here on Earth, we get a little bit of a show with the twinkles. But that's what it is. It's the light that's streaming through our atmosphere that helps to sort of like bend it a little bit. Good question. Any others? How many stars are in the universe? Oh, wow. So in a nutshell, we don't know. Scientists are discovering new stars every day, but I believe I once read that there are at least 70 sextillion, I think it was, stars in the universe. That's a lot. We can't see them all from here, but from here, I think we can see closer to like 7,000 or 8,000. But there's also this idea, everyone, if you took all of the grains of sand on every beach here on Earth, so every tiny little piece, and you counted all of it up, every little grain, there would still be more stars than even that out in the universe. So it is a lot to wrap your head around for sure. And again, scientists every day are still coming up with new ones. They're still finding and identifying new stars, and actually new planets too, exoplanets, even outside of our solar system as well. Because if you imagine every star out there, our star is a sun, right? So, hey, if it's a sun for another whole solar system out there, who knows? There might be another Earth out there too, right? But that is a topic for another program. So everyone, if you have any other questions about our programs, you can feel free to reach out to us through our website, intrepidmuseum.org, or also through social media. But I would like to thank you all so much for watching and sharing your questions and your comments with me today. As you know, the museum hosts a number of live streams, so please do follow and subscribe to any of these platforms that we've got and that you're watching today. And feel free to visit our website for our latest streaming schedule as well. Also, if you enjoyed this or any of our past programs, we would love your feedback. There is a link in the chat that I encourage you to click on to answer a few questions that will help us to plan for future sessions. Now, our next family program is Tuesday at 3 p.m., and it will be Code Breakers. So we are going to talk about some of the secret codes and the secret methods of communication that were used in the military, and you will get to try your hand at cracking a few of them from home. So once again, that is this Tuesday at 3 p.m. right here on our streaming platforms. So once again, everyone, thank you so much for joining us today. As you know, our museum is now reopened to the public 7 days a week from 10 to 5 p.m. So if you're in the area, come on by and say hello. But otherwise, we hope to see you online for another virtual Intrepid adventure. Thanks so much, everyone. We'll see you next time.